Hello everyone, and welcome to another episode of TD 101. In this episode, we will be looking at drawing a triangle that is equal in area to a given irregular quadrilateral. Stay tuned. Okay, so we're going to start off with drawing a random quadrilateral. So I'm going to draw a construction line, and the baseline of the quadrilateral will be on this line. So these are the measurements for the quadrilateral. Line AB, which is the base of the quadrilateral, will be 40 millimeters. So let me write down the measurements. So AB is equal to 40 millimeters. Then BC will also be 40 millimeters. And the angle at B, ABC, angle ABC is a 120 millimeter angle. All right. Now we need the AD and the AC. And as I said before, the only reason why I'm not constructing the angles is due to the fact that I want to speed up the process in the construction of this. So line AD, I've opened my compass to 70 millimeters. So line AD is 70. And then line CD will be 50 millimeters. So I'll now go ahead and brighten the shape. This is point D. So let me write down. So BC is also 40. ABC, the angle ABC is 120 degrees. AD 70 millimeters, and CD is equal to 50 millimeters. So that is the measurements to construct this irregular quadrilateral. Now, this method is similar to the method that you used to construct a triangle that is equal in area to a given irregular pentagon. The only difference is this shape consists of 4 sides, and as such, you are only going to connect the apex of the shape to one side. If you notice in the last video, you connected the top of the pentagon to both points A and B. In this case, you're going to connect the apex of the shape, which is here, to only one point. In this case, the apex of the shape is D. You cannot connect D to A because there's already a line there, so you're going to connect it to B. So I'm going to connect D to B. And here's the thing, you could have also used C. That's the other difference. The pentagon, for the pentagon, you use the point that is furthest from A and B, which is the top point. For the quadrilateral, you can use D or C. I could have also drawn a line from C to A, then get a parallel line from D. But I'm going to use D to draw the line since it is. So you're basically, let me show you another trick. Just pretend, please ignore this line. Do not draw this line when you're repeating it. Pretend that this shape is a pentagon. So you'd have connected D to A and D to B. Let's say that this is E. After doing so, you would have D going to B, then you would set your set square in a manner that it is equal in area. No, sorry for that mistake. So that is parallel to the line. Then you're going to transfer, use a second set square and let it act as a t-square to slide the set square along until it gets to the other point. Then you draw a line and you call this point, I'm going to call this point E. This doesn't exist, I'm just illustrating something. So this line is parallel to this line. And AE will now be the base of the triangle that will be equal in area to the quadrilateral. So over here, I'm ignoring over here. This doesn't exist. So it's basically you're doing it to one side instead of two sides, as is the case with the pentagon. So since this is the irregular polygon, the easy way to do it is to choose the highest point, which is D. If I chose C, it would have been more difficult. So this triangle, DAE. So let me write this. Area of AED, which is the triangle AED, is equal to the area of ABCD. ABCD is the irregular quadrilateral. So ABCD has the same area of AED. Alright, so that's it, people. That's how you construct a triangle that is equal in area to a given irregular quadrilateral. I hope the lesson was informative and I hope you grasped the concept that was taught in this lesson. Please remember to like, share, and subscribe for more knowledge. Have a good day.